Students, the next lesson it is chapter 6. This is science 1, refraction of the light. You can take out your textbook page number 73. We have already studied the reflection of light. You know that light travels in a straight line, and because of this, if an opaque object lies in its path, a shadow of the object is formed. But under some circumstances, the light can bend. So, what is that? When traveling obliquely from one medium to another, the direction of propagation of the light in the second medium changes. So, this phenomenon is known as refraction of light. You can see here the spoon, it is kept in a glass of the water. So, above the water, so that is air, it is there, and then this is a liquid. Okay, so looking from outside it seems that the spoon, it is been cut in the middle, or you can say it is been bent, but actually when you take out the spoon from the glass, it is not at all bent. So this means that light changes its direction when it travels from the one medium to the another. So this phenomenon is known as refraction of light. So refraction is due to what? It is due to the change in the speed of light as it enters from the one transparent medium to the another. The light travels at a faster speed in the rarer medium. Rarer medium is generally the air, and at a slow speed in the denser medium. It is generally taken as water or glass, and the nature of the media is taken as relative. It is written as, for example, air is a rarer medium than water or the glass. So when light uh, enters from a rarer medium into a denser medium, it bends towards a normal at the point of incidence. On the contrary, when the ray of light enters into the rarer medium from a denser medium, it bends away from the normal, and after emerging from the denser medium, it goes in the same direction and parallel to the incident ray. This we'll see in the diagram. You can see here, this is called as a rarer medium, this is a denser medium. When the ray of the light enters into the, this is a denser medium, from the rarer medium it bends towards the normal, and when the ray of the light enters into the rarer medium from the denser, this is a denser medium, so it goes away from the normal, and after emerging it is parallel to the incident ray. So this is a meaning. So the angle between the, this is called as an incident ray, and this is a normal, is called angle of incident and is denoted by I, and the angle between this is called as a refracted ray, and the normal is called angle of refraction denoted by R. Now based on this, there is a loss of refraction. What is a loss of refraction? The incident ray, the refracted ray, and the normal. This is a normal, and this is a boundary to the interface of the given two transparent medium. They lie in the same plane. And the second point, the ratio of the sine of the angle of incidence, so that is sine I, and the sine of the angle of refraction, that is sine R, is always constant for the light of the given color and for the pair of the given media. So this second point, it is called as the Snell's law of refraction. So this constant is called as what? Is called as a refractive index of the second medium in relation to the first. That is, second medium is this in relation to the first. And how it is written at symbolically, how you represent it? So it is represented as like this: refractive index of the second medium with respect to the first. So that is we have studied. Now refractive index, it changes, it depends on the speed of the light. So it is said that ray of the light changes its direction when it enters from one medium to the another. This why? Because the speed of light is different. For example, speed of light is 3 into 10 raised to 8 meter per second in vacuum, and it is 2.98 into 10 raised to 8 meter per second in air. So the refractive index is what? Is the relative value of the speed of the light in the given pair of the media. So in general, for a given material, the refractive index is what? Is a ratio between the speed of the light in the vacuum and the speed of the light in the medium V. If the refractive index is represented by n, then this is the given formula. First, the speed of the light in vacuum, and then the speed of the light in the medium. Now this it is there, the points are there. If the speed of the light in the medium 1 is v1 and in the medium 2 is v2, so the refractive index in terms of the velocity, how you represent? So first of all, how it is written like this. So refractive index of the second medium with respect to the medium 1, it is in the ratio of the, you can write as velocity or the speed of the light in medium 1 to the speed of the light in medium 2. Similarly, the refractive index of the medium 1 with respect to medium 2 is denoted as like this. So 1 with respect to the 2. So it will be the velocity of the light in medium 2, then the velocity of the light in medium 1. It is a ratio. What is the meaning of absolute refractive index? When one medium is taken as a vacuum, just like this. One medium is taken as the vacuum and the speed of light is taken in it, then the refractive index of second medium with respect to the vacuum is called as absolute refractive index and is denoted by n2. Just as I said this n2, so that is the velocity of the light in vacuum upon the velocity of the light in the given medium. I think this is clear to you how it goes on. Just if you want to refer to the diagram, you can see this is called as the refractive index of the second medium with respect to the first. So it will be velocity of the light in first medium, then the velocity of the light in the second medium. Now if you consider this, so this will be what? The refractive index of the first medium with respect to the second. So it will be velocity of the light in second medium upon the velocity of the light to the first medium. Read the textbook, you will become to know. You can read 74 75 page number. Then next it is the twinkling of the star. The effect, this is the due to the refraction of the light. This is due to atmospheric refraction. So the starlight, after entering the earth's atmosphere, the starlight undergoes refraction in continuous manner before it reaches the earth. This is due to the what? This is due to the change in the refractive index, because the refractive, because here the mobility of the air and the temperature is also not same. It is different at the different level. So the light undergoes the refraction continuously, so it bends towards the normal. Since the air that is above the sky, it is rarer, and nearer to the earth it is denser, so it bends towards the normal. So the apparent position is different from the actual position. Why? Because atmosphere is not changing and it keeps is not stationary, and it keeps changing. As the path of rays of light coming from the star varies slightly, then the apparent position also varies slightly, and the amount of light entering the eye flickers. So sometimes it is brighter and sometimes we see the star fade. In this way the star twinkle. Now next it is, how does a mirage form? This is also due to the atmospheric refraction. It is said that it is nothing to do with the water. Example of water it is given. It's really all about how light travels through the air. Normally light waves from the sun travel straight through the atmosphere to your eye, but the light travels at the different speed through this hot air and the cold air. What it is given, mirage happens when it happens when the ground it is very hot and the air it is cool. So the hot ground warms a layer of air just above the ground. So this hot air warms a layer. So when the light moves through the cold air, and then into the layer of hot air, it is refracted. So that means it is bent. A layer of very warm air near the ground, this is, refracts the light from the sky nearly into the U-shaped bend like this. Our brain thinks the light has traveled in a straight line. Our brain doesn't see the image has bent the light from the sky. This is the bending of light from the sky. Instead, our brain thinks the light must have come from something on the ground. So we feel that because this, what it reflects, the color of the sky, so that is blue. So we feel that there is a pool of the water on the ground. So this is a mirage is what? It is one type of the illusion. So that is called as a mirage.